So 7.1 isn't going to take us long. It's just kind of starting us into this chapter with exponents. Yeah, if it's school day, so they have to. So exponential growth and decay, which I know you've been exposed to before and you've talked about before probably. But these are essentially the three parts to what we're going to be working with. You're going to have this number right here, which is going to be just some sort of a number. Now, most people think of this as the initial population number, but not every kind of question you're working with deals with population. So they don't always call this initial population. If you're dealing with an account with money, this would be the initial amount of money. So like how much money your bank account started with. So whatever you're working with or dealing with, this A is the initial amount. Don't die on my stream. To make something exponential growth or decay, the exponent has to be a variable. So your x or your t, whatever variable you're using, is going to be in the exponent spot. The base has to be a number. Now that base number, that's an awful lot of arrows now that I'm looking at this from afar. Let's clean that up a little bit. Let's put all the labels in one color. I 100% forgot what I was talking about now that I did that.
That's no bueno.
The base number, it was something about, the base number can stand for lots of different things. So if you might have a problem where the base number is telling you that you're doubling every time. So then your base number would be a 2. You might have a problem where you're told it cuts in half every time. So then your base number would be a half. You're going to have problems where it's a percentage growth or a percentage decay. So then that number itself is going to be 1 plus the percent or 1 minus the percent. The exponential growth and decay all look similar, but there's a lot of different ways it's set up to start with. Like, you're going to work them all the same way, but they definitely can start differently. Let's just kind of do this one together just to kind of be familiar with an exponential problem. So 2 to the x. Nico, can you start? Anything up there. So we're basically just filling in that table. What's going to be the easiest number to plug in first?
Would you plug the -3 in where the x is?
Yeah, every single one of these is going to go in place of the x. I would say the -3 is not the easiest one to start with. I'm going to guess you started just because it's the first one there?
Yeah.
Okay. Let's start with the 0 or the 1, because I think that most of you would prefer to do that in your head. Probably, honestly, you guys probably think the 1 is the easiest, right? 2 to the first is 2. Do you remember what any number to the 0 power is? 1. It's been a little while since we did the exponent stuff. Any number to the 0 power is 1. It feels like it should be 0 because you guys are used to multiplying by 0, but it's definitely not. Okay, you're probably pretty used to doing squared and cubed too. So 2 squared 4. 2 cubed is, we just did cube roots last chapter. What's 2 cubed? 8. Okay, good. Now the negative powers, which I think some of you were less familiar with, that's why I waited to these. Let's do 2 to the negative third first because it's easier to explain. A negative exponent is the same thing as moving it to the other part of a fraction. So 2 to the negative third power is the same as 1 over 2 cubed. You definitely have done this before, but it's possible you might not have worked with this since Algebra 1. I don't know if that was the case or not. Have we done negative powers this year?
No.
Okay, that's kind of what I thought. So a negative exponent doesn't make the answer negative. A negative exponent, actually, if you want to know what it stands for, 2 to the third power means you multiply by 2 3 times. So it's 2 times 2 times 2. 2 to the negative third power technically means you divide by 2 3 times. So it's divided by 2, divided by 2, divided by 2. That's what the negative power actually means. So the answer is 1/8. If you divide by 2 3 times in a row, you have 1/8 of what you started with. Like, think of a candy bar. Break it in half, you have half a candy bar. Break that in half, you have a quarter of a candy bar. Break that in half, you have 1/8 of a candy bar. I'm thinking specifically of Hershey chocolates because those are the easiest to, you guys probably mentally picture those when you break things. Not only is it satisfying to break, it's satisfying to eat. Okay, so 2 to the negative third power is 1/8. 2 to the negative 2 power, what's that going to become then? 1 over 2 squared, so it's 1/4. 2 to the negative 1 is 1 over 2 to the first, so it's 1/2. Okay, now we're going to put these on the graph. And I don't think my graph goes high enough. 1, 2, 3, 4. I can't go up to 8 because I only went up to 6. So 8 would be like up here. 1/2, 1/4, 1/8. Can you see it okay? Halfway? It's so hard drawing lines on here. I don't know how people use these to draw actual pictures. I would be so bad at it. Go ahead. Okay. Now, this line basically gets closer and closer to 0, but it never actually goes negative because a negative exponent doesn't mean the answer is negative, it just means you divide by it. So like the bigger this number becomes, the smaller the answer is. So all that's going to happen is this line just gets flatter and flatter and closer to 0. And there's kind of an imaginary line that it doesn't cross. These are going to be called asymptotes. Where I got the points? See, you can ask these out loud. The points came from the table, so
Oh, okay.
so like that's the point -3 1/8.
I thought, yeah. Oh, I was just looking at the blue. That was a little more.
Gotcha.
Oh, so stupid.
Yeah, all the points came from the table we just wrote. It could have been because I wrote the table horizontally, and a lot of times we do it vertically. So a vertical table is possibly easier for you to picture them as points. I don't know if anybody else had that same question, but if you're wondering where the points came from that I got the picture from, it was from the table. Did I fly through this thing way too quick? No, this is okay. You'd be able to make your own if I gave you a different number or something? We're not going to, but if you had to, you could. Okay? Do you guys want me to leave this picture up there yet? Looks like some of you are copying it. Sure. While you guys are doing that, I'll go check on Google.
What happened? I think I'm gonna go home. Why? No, I can't stay here. No, I can't stay for lunch. Why? Because I need to go home. I don't hear a single thing you said. Are you talking to me?
No, I'm reading.
Oh. I was like, what?
Because it's life lessons.
Who's your English teacher? Oh, I've asked 3,000 times. What does that say? Asymptote?
Asymptote.
Oh, why is there a second P? I mean, first P. Why is there P?
I mean, the fact that you're showing work like that.
Okay. I think you good now? Yep.
Yep.
I believe the next slide I want to back up from here. So, knowing the difference between growth and decay is going to be a big thing. This would be considered growth because the answers were getting bigger as we went to the right. Decay would mean your answers get smaller as you go to the right. Yeah, this one is growth because your answers are getting larger.
Huh?
Okay. 3 to the x. Who should we go with? Let's go with Dylan. Dylan. It's not on the show you're currently watching.
No.
No. How do we know if the answer's getting bigger or smaller?
If there's a negative in front of the page.
That's actually not a bad idea. Actually, virtually none of the things we're going to be working with are going to be negatives. Or negative answers, I should say.
Mm-hmm.
So growth and decay is only different in that your answers get larger. And decay means your answers get smaller, not necessarily negative. But that's good reasoning. Bad writing. Hopefully you can read that semi. So 3 to the x. Jack, would these answers get bigger or smaller as you put numbers in?
Probably
Bigger? Okay. If you're not sure, plug in 1 and then plug in 2. If I plug in 1, the answer is 3. If I plug in 2, the answer is 9. So then the answers were getting larger. This would be growth. Yeah, go ahead.
Be decay then.
Say what?
What would be decay?
Oh, that I was going to put multiple ones up here. Gotcha. So 1/2 to the x. If I plug in 1, the answer would be 1/2. If I plug in 2, what would the answer be? 1/4. 1/2 squared would be 1/2 times 1/2. So that'd be 1/4. This one would be decay. Ready for more annoying? Okay. 3 to the negative x. Why is this one decay?
I don't know, I just found.
Okay. Just using staging, like knowing what the answer is going to be.
Yeah.
So if I plug in 1 in place of x, I would get an answer of 3 to the negative 1, which would be 1/3. If I plug in 2, I'd get 3 to the negative 2, which would be 1/9. So these answers are getting smaller. Growth and decay can look different. Now, there definitely is one thing we can look for to try to determine growth and decay. But I want you guys to realize the easiest way to figure out the answers is just to figure out if the answers are getting, when I say answers, the easiest way to figure out if it's growth or decay is to figure out if the answers are getting bigger or smaller. Most people can do that by plugging in 1 and then 2.
So you don't always have to do that XY chart.
No, it kind of depends on the problem. It absolutely depends on the problem. Okay, so I have this up here. This is going to be when you have percentage growth or decay. This formula is specifically for percentage growth and decay. That's not a marker. Go ahead. Okay. Now, on the previous page, the equations could look all different. On these, the exponent is just a regular x each time, and so growth and decay is always going to be this. If your base number is bigger than 1, it's going to be growth. If your base number is between 0 and 1,
And that's a 1.
I don't know what we're talking about. There's no L's up there. There are
Okay,
ones.
So it's 1 plus R.
Yes.
One marker.
Yep. They kind of look. I know they kind of look like L's. Hi.
Hello.
Thank you. How are you doing?
I'm good. How are you?
Good. He's not here today. Thanks, though. Yep. You're getting your steps in. It's okay. So if you have a problem that says like your bank account starts with $500 and is growing at a rate of 3% per year, this would be the type of equation you're going to use to find that answer, where A would be the amount you start with, and then R is growth rate or decay rate. So like we would put in 0.03 in place of R. And I'm trying to hold these notes to like very little because we have a couple word problems we're going to do, and I know those take a little while to write down. And so I'm trying to go through this stuff a little bit faster. Nico, is that the pomegranate one again? I keep forgetting to try that. You bring that one all the time. Sounds good. Does anybody need this slide up here yet? Okay, let's do this problem. Oh, did you say yes?
No, it's okay.
So a culture containing 150 bacteria doubles in population every hour. Predict the number of bacteria after 12 hours. Now, on the previous slide, do you remember what I told you that formula was going to be for? Percent change, right? Now, when we're reading through this problem, there's not a percentage. So we're not going to use that specific formula, but we're going to use like a version of it. And that's why I kind of wanted to get to word problems, just because these questions are all similar, but they're all worded differently and set up slightly different, and I know a lot of students get thrown off by that. Were you done already?
Yeah.
Oh, did a lot of you guys finish fast on Friday? I didn't even ask that. Oh, okay, good. That's definitely good. Thank you.
Shockingly.
How do we write something doubling?
Times 2.
Times 2.
Exponent of 2.
Close. That's kind of why I wanted to put this. So if I double something, we wrote times 2. If we want to double something again, times 2. And then each time we double, we put times 2, right?
Yep.
So rather than us writing 2 times 2 times 2 times 2, we're going to write how many times we're going to double it as exponential, like that. So if we double something twice, we would put 2 squared. If we double something once, 1, 2 to the first, this power represents how many times you're doubling. But now this formula itself can't just work with doubling, because what are we doubling? The 150 that we started with. So we're going to have a starting amount and then number of times doubling it. So after 1 hour, I would have 150 times 2, because that would double once. After 2 hours, it's going to double twice, so that'd be 150 times 2 times 2 squared. This one specifically asks for 12 hours, so then we're going to plug 12 in. And no, I'm not expecting you to do these by hand. If you don't have a calculator on you, I'm okay with you leaving the answer like this. Yeah,
On the test, are we using a calculator?
definitely. Yep, definitely.
So we couldn't leave it like that?
If the test is set up for no calculator, then I would just have you write that out and leave it there. I'm assuming somebody plugged this in. I know it's going to be like probably millions at this point.
That's 614,400.
Oh, all right. Well, if you would have doubled it one more time, then it would have been millions. Somebody else get that? Perfect. And that's a lot of bacteria. I'm assuming you guys have done this in science class already, right? You haven't done the bacteria thing in science classes? What grade is that?
Bacteria thing. What is the...
Is that chemistry?
Well, I'm confused on this one.
I would have done it like 8.
Like, are you asking what type of answer you should put, or what?
Like, I don't.
What would be the new equation after it's reflected across the x-axis? That's what you're supposed to write as the answer.
Oh, and then this one, don't write standard form, but that's standard form, isn't it?
That's not standard form. Standard form would be like this.
Oh, okay.
So the way you have it written is fine on that one. I'm assuming that must be like physical science, but what grade is that? Is that 9th grade? You guys haven't done the bacteria?
I don't remember. I have pretty bad memory.
That used to be a super standard thing where they would have anybody just take their hand and put it into the culture.
We did that.
What?
We did that.
What?
We did some.
Like it's usually a circle with like gel or goo,
Oh, we did that.
and then you put your
Ninth grade.
finger in there
Yep. Come
to
on.
show like how many bacteria are on your fingers.
I remember doing that.
And then you probably like used hand sanitizer or something and then did it in a different one. Okay, well,
Something
whatever.
like that. I remember
Yeah,
doing that.
bacteria grow really fast.
Was my knife get broken?
That's
We
like
did that, like,
if you guys have a bacteria infection, you don't usually feel it at first, but then it just kind of like grows. And then it just hits you. And that's because they grow really fast. Okay, now I didn't write these, so they're. Let me make it bigger. Is that good enough? Okay. Kate purchased a guitar in 2000 for $12,000. Its value will increase by 14% each year. When will the guitar be $60,000? Put that away. Eva.
Sorry.
Now, before we even worry about the $60,000 part, we're going to worry about the equation that's used to get that answer. Now, we are going to have a question like this on the test eventually, and there's going to be different ways to solve it. I'm trying to decide what you guys would find easiest. I have a feeling most of you guys prefer guess and check than other methods.
Does that say 12,000?
That does say 12,000. I can't remember who wrote that. I had a student go up there and write it, but they write their zeros weird. They write the zeros with the line through it, so that it's not an O. I mean, I say weird, but I write weird too, so I'm not worried about it.
What is that second number? 14%. Oh, 50%.
Yeah,
I'm too serious.
I'll rewrite the percentage for you. I really like their question mark though. That question mark is cool.
That's like the question marks in Spain. Too.
Spanish don't have different question marks.
Yeah, you read them upside down.
Well, that doesn't mean a question mark though, right?
I don't know. I was.
Isn't it just an upside down question mark though? So whatever font you use, doesn't it just flip it upside down?
I don't know.
Oh.
I was only in class Spanish for like a try. Then I switched.
I took German. I didn't take Spanish. Okay, starting amount, 12,000, because that's how much the guitar was purchased for. Now, it doesn't say doubled or halved or something like that. So this one gives us a percent. So I'm going to have to use that formula that's 1 plus or minus a percent rate. To determine if you put a plus or a minus, you have to determine if it's growing or decaying. Is the answer getting bigger each year or smaller? Bigger because it uses the word increase. It would probably say decrease if it meant for decay. It could possibly use the word growth or decay, but they usually don't use those specific words. So I know it's getting bigger, so I'm going to have a plus. Now, we're technically adding 12%, but most of your calculators can't put in a percentage symbol. Some of the calculators do let you type in it as a percent. Most of them don't. Most of them make you type it as a decimal. So this would be 1 plus 0.12. So 1.12. Oh, where did I get 12? Mm-hmm. You guys definitely need to learn to yell at me. Sometimes when I'm trying to talk and explain while I'm writing, I write wrong things. Yes, it should have been a 14, not a 12.
It's a 14. Yeah, I was gonna say, why did you do 12?
Well, you should have said that a lot earlier.
Well, it was just in my head. She doesn't say.
How do we figure out when this is going to be $60,000? Because that's what this one's asking us. Now,
Sure, not quite sure.
we are going to learn a correct way to solve this later on.
Will it be exactly 60,000 or?
No. So when it says when will the guitar be worth $60,000, the way our formula is currently set up is we're just going to go by whole years. You can have a partial year because the way this formula actually goes by like individual days if we want, but so I'm assuming the way that you guys would like to solve this is just to plug numbers in place of T until you get that answer. Is that correct? Or there's going to be different ways to find this answer, but I feel like you guys generally seem more comfortable just plugging in numbers and getting answers. And I'm okay with that too. I don't need to show you a different way if it's easier for you just to try that. So plug in 10, see what kind of answer you get. I think 10 is too small if I remember right. What was the answer?
44,486.65.
Okay, definitely too small. I don't know, 12? In between what? Perfect. So then the way you would show this answer is just to show your work of what it's between. So what's 12 years? $57,814. Okay, and then 13 years is obviously over 60. Did you get it, Faley? Maybe.
65908.
Perfect. Thank you. So the guitar would be worth $60,000 between 12 and 13 years. And I'm okay if you want to answer 13 years or after 12 years or something like that. I find it easiest just to be kind of most specific. And then if you answer it like that, then it's kind of hard to argue what you intend. But when you get a question like this on the test, I'm going to be pretty lenient. Okay, this is about as difficult as you'll get. Most of the questions are just going to be like the previous one, where you're going to be asked to plug in a number in place of the power. Or you're going to be asked to come up with an correct equation. The homework itself is split. Half of the questions are asking you if it's growth or decay. I think there are 6 questions that ask you if it's growth or decay. So that's usually something that's like an instant answer. The other 5 questions, I believe, because I think there's 11 total, maybe 4 questions. Must be 4. The other questions are word problems, similar to our last 2, where you're going to have to come up with an equation and an answer from that. Overall, the homework shouldn't take very long. I mean, we've got 10 minutes left now. I don't think you'll get it done in 10 minutes, but I could be wrong. Some of you are very quick on the calculator, and that's probably what would take the most time. No, 4 word problems, 6 where you just answer growth or decay.
Oh, yes.